Hello, my name is Victoria Gamlar, and this is CE 6370.001, Design and Analysis of Reconfigurable Systems. This homework is FPGA soft IPs for CORDIC. So there's Cordis, went to the library, basic functions, arithmetic, and then ALTERA CORDIC. And then generated the IP, which generated these code files for VHDL, and then here's the source code, and then I created the test bench, and then I will compile the design and show the results. It finished compiling, and so looking at the results, we have 141 ALMs, 263 ALUTs, and then checking timing analysis, timing analyzer, and in the timing analyzer there's report path to get the critical path delay report path. And the delay is 14.171 nanoseconds. Specifically, I'll compile the FITR. From the FITR compilation and the timing analysis, we got 150 ALMs and 264 ALUTs. And then timing analyzer. Report path. Okay, and we got a delay of 14.171. Alright. This is the test bench of sine cosine. And there's the phase increment, which is pi over 2, which is this decimal number 0.392, which is estimated in binary. The closest binary representation is 0.390625, which is this binary here. And then the phase is also called A in CORDIC component. And then once we run simulation, compile, and select the test bench, then get the test bench from work, and increase the runtime, which then you can see positive and negative. And zooming in, we see that, so first is incrementing positively up to pi. Once it reaches pi, which is 192 in hexadecimal, it then increments down and then increments up to check the values of sine and cosine to see that they are properly changing. And that is our working test bench. And next we will prototype on the Terasic board. So prototyping will be in program device. This is prototyping on the Terasic board, and currently this is on pi, so that is correct with -1 for cosine and sine is 0. And then we got this from the download IPs from ALTERA CORDIC, which is the Cordis IPs. And then furthermore, so if we switch from pi to -pi, this is the sine bit, this is the 0, 1, and then 3, and then these are the fraction bits. So switching to negative pi, we see we get the correct result of 0 from sine and negative 1 from cosine, and then switching to 0 input. We get 0 for sine and 1 for cosine, which is correct. Sorry about the blurriness. And then switching to pi over 2. And we get the correct output of 1 from sine and 0 from cosine, and switching to negative pi over 2. And we get the correct output because so sine negative 1 and cosine is 0. And this is the correct inputs and outputs. Also just clarifying, so the first 5 LEDs are sine, last 5 LEDs are cosine. Thank you.